Hey guys, we're back. Sorry we kept screwing up. Mr. Bedella was just laughing way too much. I don't know if you noticed, but we changed clothes all of a sudden. So
That's right.
we have to come back the next day and try this again. So let's try to get this here.
So we're going to try it.
There you go. It's cold outside.
It's cold outside.
So
we've got parallelogram ABDC is similar to parallelogram RSUT, and we want to find the scale factor of RSUT to ABDC, and we want to find RT, CD, and the measurement of angle U. So if we look at this, now they've already told us that they're similar, and so we've learned that if it's a similar polygon, that means they have similar angles in the corresponding spots. So if angle C is 60 and angle T is 60, then that means that if angle D is 120, that angle U must also be 120. And there it is. Okay? So now let's start trying to find RT, CD, and the measure. We already got the measurement angle U. So let's try to find RT and CD. The first thing we want to do is we want to start to make some ratios. So if we look at this, we can make the ratio of 24 to 18 because that's what's given to us right now. And that is AB to RS. Okay? And so if we reduce that down, all right, one number goes into both. Okay? 6 does, and that gets us down to 4/3. So there's our scale factor. So at the smallest increments, it's going to be a ratio of 4:3. And now we can start to look at, trying to figure out RT and CD. So if you look at RT is the corresponding side to AC, and since they're going the bigger one on top and the smaller one on the bottom, we can call it 4/3 is congruent to RT over 9. We've got the scale factor in the front, okay, equal to the side we're missing over the corresponding side on the similar polygon, which is 9. Okay, and then if you cross multiply and divide, so 9 times 4 is 36, and 3 times RT, we call that 3x. Do a little bit of math, move things around, and you get that RT is 12. Okay. Now you already see the other piece of information just flew in. All right, and that is for CD. All right, and if you're looking at that, all right, CD corresponds to TU on the larger polygon. So all we do is we take that 4/3 scale factor and we set it equal to the larger side over the smaller side, which we don't know. Cross multiply again. Okay, 4 times CD, we'll just call that 4x. 3 times 20 is 60. Do some division, and you get 15 is the length of CD. Okay. So, hey, it's right back to what we were doing before, guys. Just setting up proportions and then cross-multiplying and working things out. And that's all there really is to it. Okay? Find that initial piece of information, reduce, and you got your scale factor. Anything else, Mr. Scritch?
Nope, just some algebra there.
Okay.
Yep. So, once we know that the sides are in proportion of the polygons that we're looking at, and again, we're normally going to be looking at triangles, but it could be any kind of polygon. Once we know those sides are in a ratio, then this theorem tells us that the perimeter ratio is equal to the ratio of the corresponding side lengths. So on that last example where we had side lengths that were in a ratio of 4:3, that means the perimeters would be in a ratio of 4:3. And that makes sense. All you're going to do is just add up all the sides, and so if the sides are in a ratio of 4:3, so will the perimeters, because we've just added up the sides. And so you just need to remember that. Perimeters of the polygons, there'll be questions on this. Perimeters of the polygons, of similar polygons, the perimeter ratio is the same as the side ratio. Okay. The lengths of any other segments within a similar polygons will also have that same scale factor. So let's say that we were looking at 2 triangles that had medians or mid segments or whatever. The length of those segments is going to be in the same scale factor as the sides of that triangle. And so basically what these two theorems are saying, that everything within the shape that we're looking at, if they are similar to each other, then the ratio of those is the same as the ratio of the sides. Anything else there?
Nope.
Pretty straightforward.
Everything's proportional with one another, guys. Doesn't matter what piece.
Yeah, we're just going back to section 1 and 2 of setting up ratios, solving proportions. Same thing.
All right, so in the diagram here, we've got polygon A, B, C, D, E is similar to polygon FFG, H, J, K, and they want us to find the scale factor from the larger polygon to the smaller polygon. Okay, so to do that, guys, just try to find two places where you can compare one another. And so if you're looking at this, okay, we on the bottom one we've only got AE, which is X, and AB, which is 10. So to find the scale factor, you just got to look at this and match it up. So if you look at the order in the original diagram, it said that AB CDE was similar to FG HJK. So that means that side AB is similar to side FG based on the order that they have the polygon going around. So you can make your scale factor out of those two right there. So we're gonna make that scale factor of it's either going to be 15 over 10 or 10 over 15, depending on which way they go here, and it's larger to smaller. Okay, so there's a scale factor almost. What do we got to do? Reduce it. So if we reduce that down, we get a scale factor of 3 to 2. So that's how we came up with that scale factor of FG to AB. All right, and now we want to find the perimeter of ABCDE polygon. Okay, and so all we got to do now, guys, or first we got to find the value of X, sorry. So let's set up a proportion here. 3 over 2 equals 18 over X, okay? Cross multiply, 2 times 18 is 36, divide that by 3, and we get X is 12. Okay, so now we know side AE is 12, and so to find the perimeter here, all right, all you got to do is take the perimeter of the larger one and use that same scale factor and make your proportion, and you should be able to come up with your answer. So I've got 3 over 2 equals 69 over X, okay, and the 69 comes from 18 plus 15 plus 9 plus 12 plus 15. That gives you the 69. Remember what Mr. Scritchfield just said on the previous slide. The perimeters are also part of the same scale factor, so now all you got to do is cross multiply, and you get 138 over equals 3X, and we get 46. Okay? So pretty straightforward, Mr. Scritchfield. Anything you want to add to that?
No, just make sure that you catch what Mr. Badella was saying there. In the original statement up there, the ABCDE is similar to FGHJK. Just like when we had congruent triangles, you could pick out the first 2 letters in that list on one side, the first 2 letters on the other side, and those 2 sides then would be in proportion to each other. And you could do that in the same order throughout both of those lists. And so you can either get it from the diagram and see which ones land on which one, or you can get it from the similarity statement and find which ones land on each other. So, all right. Okay, now, just like we had shortcuts when we were talking about congruent triangles in Chapter 4, we had side, 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 angle, angle, side, angle. We had all those shortcuts to having to prove all 3 sides and all 3 angles. Well, we have shortcuts when we're talking about similar triangles as well. And so, we actually had a theorem back then that was called the third angle theorem that said that if you know 2 angles of one triangle are congruent to 2 angles of another triangle, the third angle also had to be congruent. And that stems from the fact that all 3 angles have to add up to 180 degrees. So that kind of gives us this theorem here, that if 2 angles of one triangle are congruent, they have to be congruent. When we're talking about the angles, we're talking about congruence. When we're talking about the sides, we're talking about being proportional, or be in a ratio to each other. But the angles have to be congruent. So if 2 angles of one triangle are congruent to 2 angles in another triangle, then the 2 triangles are similar to each other. It forces it to happen. If the angles are congruent in that way, then the sides have to be in proportion. They have to be blown up or shrunk down in the exact same way. It's the only way that it can work for 2 triangles. And so, are these 2 triangles similar to each other? Triangle ANT and HIL. If we look at the 2 angles that are given to us in each one, we have a 90 and a 39 in the small triangle, and so if we subtract the 39 from the 90 that's left over, we would get 51 degrees for angle A. And then if we subtract the 51 in the bigger triangle from 90, of course we're going to get a 39. And so the 2 triangles have angles that are congruent. It's just one is blown up or shrunk down from the other one, and if that blowing up or shrinking down is going to happen, it's going to happen proportionally. We're not stretching it out one way more than the other or anything like that. It's all happening proportionally. So in order for us to get this, we have to think back to our congruent triangles of how they landed on top of each other. So one of these is going to have to kind of rotate around or flip over, reflect, however you want to talk about that. It's going to flip over and land on the other one. So H is going to land on A, I is going to land on N, and L is going to land on T. And so that's how we're going to write our similarity statement. So in this case, triangle ANT, the small one, is similar to triangle HIL. Mr. Bedell, I think that's funny. It's like an anthill or something. Whoever made these slides, just their sense of humor there. So those two triangles are similar to each other. Anthill. All right. Anything else there, Mr.
Nope.
Bedell? Okay.
It's red too.
It's red.
Red
ants. Red anthill. Be careful. Don't get near that.
All right, so let's look at it again here, and can we decide if these two triangles are similar? If so, write a similarity statement. So let's look at these first here. Well, if S is 35 and T is 35, we're kind of the way there, but 85 and 65 are definitely different. But remember that triangles are bound to 180 degrees. So if we look at that, if we figure out what angle V is and we figure out what angle R is and they match up, then we might be able to say that these triangles are similar. So let's go ahead and do that. So let's add 35 and 85 together, subtract it from 180, and you get, let's do that. So 35 and 85 would give you 120, guys. And so that means that R has to be 60. Well, if R is 60, okay, that's definitely not going to match up with angle U at 65. So that's why that not's there. I just wanted to go back and do that. And so then we say that they are not similar. Don't forget that the tilde is right there, so that's the word for similar, so we don't have to write it out every time. All right, now let's look at these. So you've got two triangles here. Would we be able to prove that these are similar, not congruent, similar? Now remember, here we come back to good old transversals. You see those parallel lines in there, and you got to remember that there's some alternate interior or corresponding and vertical in there that you're going to have to think about. So you should all see the vertical angles between SVR and TVU right there. And then you should also be thinking that angle S and angle U are alternate interior, and angle T and angle R are also alternate interior. And so we get that, and that. So we have three angles. Well, we only need two for AA, so would these in fact be similar? And the answer is yes. Okay, and now just make sure that when you go to match these up, when you make your similarity statement, T has got to match up with R, and U has got to match up with S, and V has got to match up with V, because those are the corresponding angles, guys. And that'll be the mistake that most of you guys will make. You'll see the similarity, but then you'll mess up when you go to make your statement, because that's the one part that still eludes you a little bit.
Yep, that's it. Yeah. Oh, we got another example here.
All right, so this one right here, guys, it's going to seem a little bit tricky at first, but you just kind of got to work through it and see how things match up. So if you look at the big triangle, YWU, what you want to do there is figure out that third angle. And if you do that, 85 and 50 is 135, so that gives you 45 degrees to work with. So if you look at that, all right, what you need to see here is that angle Y is reflexive between the bigger triangle and the smaller triangle of YXZ. So if that's 85 and that's 45, and you got 85 the reflexive for both, and then angle U and angle X are both 45 degrees, then you know that Z will also be 50 degrees. And all they did was kind of flip that triangle, that smaller triangle, around on the inside and adjust that little segment. You can see it's not parallel to the bottom there. And so would these be similar? Yeah, because if you look at it, you can make the similarity statement of triangle YXZ is congruent to, or not congruent, similar to triangle YUW, because Y is 85 for both, X is 45 and U is 45, and W and Z are both 50. So just pay close attention to the information. Don't always just look at the drawing and make a snap decision, guys. Do the math first.